So, as I was saying, after distributing this MGL, the next thing that we see is that when looking at the rest of this expression, we know that there's a correlation between KMI nominal and MGL sine of theta nominal based on what we did before. We know that KMI nominal is equal to this, and so we know that these two terms are identical, so we can just cancel them out for both sides of the equation. So then what we're left with is just this guy for our equation motion that's dealing with theta nominals and I nominals and theta dot or theta tildes and all that jazz. So the next question is, if we were to try to complete a block diagram for the system, how would we do this? And so the first thing that I think about when trying to fill in a block diagram is, what is the overall output of the system that I'm trying to attain? And so if I look at the circuit, the main thing I'm concerned with is what is the output? Like if I was a factory and I was pumping out a product, what product am I trying to produce? I'm trying to produce some form of theta, which is in the grand scheme what I'm really concerned with. And so what's going to come out of my factory or my plant is just some theta. And then let's say if I have this circuit here, okay, I produce some theta, now what? Like, what do I do with that? I have to compare it to some nominal value to then say, all right, well, if this is under what I want or over what I want, how much current then do I need to change to produce the next theta that would be closer to the nominal? And so what you do is you say, all right, well, this is my experimental, let's say my experimental value, or like in terms of cars, it'd be like cruise control, where it's like, okay, this is the velocity that I'm going at, but I don't want to be going here. I want to be going at some other velocity, so I need to compare it to some nominal desired value that you set. So we're going to compare this guy to some theta nominal, and as we said before, so we're after comparing our theta to our theta nominal, that comparison being theta minus theta nominal, so it's going to produce some error associated with the theta, so that the output of this guy is going to be theta tilde, and then that is going to be fed into the control law, which is basically like in your car, it's saying, okay, this is velocity I'm going at, this is what I want it to be. Now, what kind of torque do I need on my motor for my engine to be able to produce the right velocity I want? So in a similar fashion, this control law sees this theta value or this theta tilde and says, all right, now I need to produce some change in my eye, or a disturbance like in the eye, to then produce some other, some actual current to flow through this thing. So I need to then say, all right, this is the change in I that I want, and I need to compare it to the nominal current that I previously figured out. I need to compare it to the nominal, sum those two up in the summer, and then that's going to produce what? It's going to produce some current I, which is then going to be fed through this circuit. It's going to be multiplied by Km, and knowing that Kmi is just equal to Tm in this equation. So we're feeding in again a Tm minus T load here. And then after we sum those up and pump it back into the plant, it's like, all right, well, this part of the equation is then going to be fed into the plant, and it's going to produce what? It's going to produce some form of function that is dependent upon my theta values. And so we see that's exactly what takes place here. So the main way to think about it, once again, is that what am I trying to produce is thetas. I need to compare it to some nominal value to then pump it out and say, all right, I need to change what? I need to change the current coming out of here. And then that gets fed back in, inevitably finds its way back into the plant. And so that's generally how you want to think about how PID works. So yeah, I hope that was helpful.